here's what we're going to be covering today. I want to cover the trig functions on obtuse angles today. This is something we have not covered yet, just to make sure that we know how to do it. And I want to explain something as we get going here. We've been doing, if you haven't noticed, every example I've given you up to this point, the angles you've had have been acute. So that means all the angles are less than 90 degrees on something, on some type of problem. I'll kind of do an example here in a second of that, something that you have in your homework that you need to be aware of how to do. But we are going into obtuse. Now, this requires a couple different things. So here, I'm going to list off the things we're going to need to be aware of for the new stuff we're going into. You're going to need a positive, negative sine chart. This is something, I don't know if you've seen this before. You need the positive, negative sine chart. I'm going to provide that to you today. That's kind of one of the main pieces. It's actually like the next major slide we're going to go into. After the positive, negative sine chart, we also need to know the special triangles. I was going to do these yesterday, but I think today is kind of more of an appropriate day how to do the special triangles. And then the last thing, if you're not aware, is the reference angles. So these are ways of making angles smaller so that we can actually calculate them if we're going to use the special triangles. So, but I want to talk about what the numbers are. And so this is going to be just a light introduction today. I might go about 15 minutes in and give you a bunch of time where you can just kind of work on the assignment that I gave you yesterday. Assignment I gave you yesterday was, I think I called it worksheet 4.2. It's due tomorrow, so keep that in mind. Tomorrow we're on an early out schedule, so if you're going to Zoom from home tomorrow or anything like that, remember we're on a different time schedule tomorrow, so check the email. I try to send an email every morning to kind of remind you what time class starts, what the links are. So, what? What?
Just occasionally stay home and Zoom.
No. So, no.
Because the school doesn't get money?
Yeah, so just, hey, if you have questions about that, talk to the office. I don't want to discuss that. All right, so let's get to some major math today. So first thing, positive, negative sine chart. Let's talk about that. So positive, negative sine chart. Okay, all right. So, on your positive, negative sine chart, here's what you need to know. The quadrants. I'm going to put the numbers up here. Quadrant 1, quadrant 2, 3, and 4, they go counterclockwise because of angles. 3 got a little messy there. My palm is really messing with that today. All right, so quadrant 1, 2, 3, and 4. Now, welcome back. All right, so here's the idea. When you're in quadrant 1, and I'm going to try to highlight this as best as possible. When you're in quadrant 1, all trig functions are positive. All trig functions are positive here. So no matter what angle you pick, they're all positive in the first quadrant. Okay? So, for instance, if you pick, 70 degrees and you pick any of the 6 trig functions, cosecant, secant, tangent, cotangent, whatever you pick, you're going to get a positive number in a calculator no matter what, as long as you're in degree mode. Now, that could be any angle from, 0.9 degree or 0.1 degree all the way up to 89.9. All right? Now, when you get into the second quadrant, now only specific trig functions are going to be positive. The ones that are going to be positive are sine and cosecant. These are the only two that will end up being positive on a calculator. You'll get a so that's if you're in any angle from 90.1 degrees up to 179.9 repeating degrees. Every other trig function will be negative there. So if you want just an example here, I'll give you an example on my calculator screen just so you can see this. Okay. All right. So if you're in your calculator and you're going to type in let's say like cosine of 120 degrees. Since it's not sine or cosecant, this will be negative. So you get some negative decimals. So if I typed in sine of 120, you get a positive number. Because of the quadrant you're landing in. Now, I'm going to explain why today. That's kind of the idea. I want to introduce that. And then, introduce the special triangles for the first time. Again, I don't want to go too far in depth because I want to give you some time to work today on your homework that you have and do an example of that. But this is kind of the main goal today, is to talk about those trig functions. Now, if I keep going, I'm going to keep spinning here around the picture. If we get to the third quadrant, tangent and cotangent are positive here. So if you're in that fourth quadrant, these are the or third quadrant, those are the ones that are positive. So if you're in, from one tangent, cotangent. So if you're in the third quadrant, that's anything from like 180.1 to 169.9 repeating in terms of angle, or 269.9 repeating. And then in the fourth quadrant here, this would be cosine and secant. These are the ones that are positive in the fourth quadrant. Now, I do want to explain why. I'll just do it for the second quadrant today, just so you can see this. It'll kind of touch on pretty much everything we need to cover. So, all right. But yeah, this is a positive and negative sign chart. I don't know too many textbooks that ever cover this. This is something, when I'm looking at angles, I can already tell you what the answer is in terms of negative and positive by just knowing this chart on the back of my mind. I don't need to worry about what the calculator is going to tell me. I know it's going to end up being negative. So, like an ACT or an Iowa test, a basic skill, or whatever you have, a smarter balance test, whatever you're going to take. Sometimes they ask, a simple question like, what is the secant of 300 degrees? Well, if you're in 300, that means you're in the fourth quadrant, so I know it's going to be positive. So I can already eliminate the two negative numbers in the list if they give me an A, B, C, D. So that's a quick way to process elimination because of what quadrant I land in. Now, I want to discuss why is sine positive in the second. I just want to give you that idea, and then tomorrow we're going to really kind of hammer these down. So why is sine positive in the second quadrant? Let's go through that example. So if you land in the second quadrant, so I'm going to make a really big example. This is supposed to be the Cartesian coordinate graph. If you're in that second quadrant with an angle, so an angle starts here. This is normally how you draw angles in standard position. The angle opens up and you end up in the second quadrant, right? Well, when you're doing the sine function of it, what it uses is what they call a reference angle. The reference angle is this angle over here that brings it back to 180. So it's using this angle here, not the angle on the outside, the big angle, the obtuse. It uses the acute angle left over. So if it was actually doing, let's say what I gave you earlier, I think when I typed it in a calculator, I think I typed in 120, right? So I typed in the 120. What you actually do is you actually subtract it from 180, and that's your reference angle. It brings it back to 180. So if I take 180 and I subtract the 120, this angle it's actually going to use on a calculator is actually 60 degrees. And that's why it ends up being positive, because where you land. So it's actually used a 60-degree angle in the second quadrant, and it turns out to be positive. In fact, let me just show you on a calculator that it actually gives you the same result. So sine of 120. So sine of 120 and the sine of 60 degrees. They're giving me the same number. It's a reference angle. It's giving me the same result. Because they go off the same numbers in terms of special triangles. And now, why sine will always be positive? Why is it giving you a positive 0.86? It's because what sine stands for in terms of SOHCAHTOA. Sine stands for opposite over hypotenuse, right? That's what sine stands for. And so when you do sine, if this is my angle right here, let's say that's my angle, I'm using the 60 degrees. When I do this, this is the opposite wall, and this is the hypotenuse wall. Well, in terms of numbers, to get to this dot right here, to get to this coordinate, the opposite wall is going up. What numbers are up on the y-axis? Positive numbers. So that's a positive number going up. And then this hypotenuse is always positive. It's a distance from 0 straight out to here. This will always be a positive number, because on the Pythagorean theorem you'd have to square it to get to that number. So in terms of both numbers, the opposite is positive and the hypotenuse is positive, so you always get a positive number. And that's why it's coming up with 0.86. Now, in terms of special triangle, why is it giving you 0.86 on a calculator? There are certain triangles out there that we use for calculations. One of them is, there's two, called the special triangles, and I'd like you to have this triangle kind of written out here. This is something you need to know. This is your intro today, and we're going to do a couple of these tomorrow. The special triangles, there's two. I'm going to just show you one of them today. One of the triangles is called a 30, 60, 90 triangle. So I don't know if you've ever seen these. You should have seen them in geometry days, but maybe algebra 2 you cover this a lot. I have no idea. On a 30, 60, 90 triangle, the triangle has specific lengths for the walls. They use them for design and architecture and construction. They're used pretty much everywhere in terms of design. The roofs of your house are based on a 30, 60, 90 or a 45, 45, 90 triangle, unless you have a flat roof. But they're always based on these because the A-frames are just built in set, sizes. Here's the walls you need to know. So across from 60 here, this wall is the square root of 3 in terms of distance. It's a multiple of square root of 3. The side that is opposite of 30 is always a multiple of 1. And the side opposite of 90 is the multiple of 2. So if you know one of the walls, you can multiply them by all these numbers, and it would give you that distance that you're covering. So when I actually do the sine of 60, I'm using this opposite wall to 60, and this is the hypotenuse to 60, right? I don't know, I just wrote hap, but height. All right, so this is the opposite over hypotenuse. So that's root 3 over 2. And so, bless you. And that's actually the number that we're getting here. So in fact, if I go back to my calculator here, so let's go back to the calculator that I just typed a little bit ago. The square root of 3, so if I type in the square root, so the square root key is right here, square root of 3, close that parenthesis off, I need to do that. Square root of 3 divided by 2, get the same number. So it's using special triangles to actually calculate trig function. So I know this is going to seem really weird, every angle you can possibly come up with, you can make some weird combination using special triangles. You can add, subtract, multiply, and divide, special triangles together in such a way that you can make the angle you're looking for. So if I'm looking for a 15-degree angle and taking cosine of it, I can use a 30, 60, 90 triangle to get to 15 in terms of numbers. So it's kind of weird when you actually start to think about the implications of what it's doing. And so that's what we're going to look at in the later section. That's chapter 5 materials, like how do we convert stuff. So I think chapter 5 is the more challenging part of chapter 4. It's like it's trying to figure out how to do weird stuff without this thing in your hand. So that's what we're going to do later. So, okay. Questions on the intro to what we're going to be doing tomorrow?
Nope.
Okay. Now remember, your homework assignment today is to solve right triangles. So I think one of the questions I got yesterday was this one particular question. It was something like this, and I think it had. This was like a 37, this was an 18 or something like that. And it wanted to know this number right here, the distance between this dot to this dot. And this was some angle over here. Or this is some wall, I don't know what this number was exactly. Let's say it's like 50 feet, I don't know what this number was. And you had to find this x over here. What you have to do is you have to use this 50 and this angle right here, because I can find this angle, because it's whatever's left from 90 when you take away 18 and 37, and I can use that to find this wall down here. Then I can do the same thing for this triangle over here. I can do the same exact work because I can do this entire angle to find this wall across from it, this entire wall. When I subtract the entire distance minus y, it gives me x in terms of length. I had a lot of questions yesterday afternoon about this specific question. I don't know if these numbers are exactly right, but it was just a lot of people were getting confused on what you needed to do on that problem. You have to find that weird yellow angle solve for y in that triangle using, I think, tangent. Then once you have that yellow angle, you can add that with the 37 and do the tangent again to find the big wall down here, to find D. Okay, same exact thing. Tangent of that angle using the 50 will help you find D. Okay, questions with that one question. I'll leave that up there. If you want me to solve that out, I can do that. I want to give you kind of a hint what you needed to do there on that problem. I was just getting a lot of questions from you yesterday. Homework's due tomorrow. That's the worksheet. We'll continue on with this new stuff tomorrow. I might even give you some property sheets tomorrow that will help you guys out. So expect those tomorrow. They're not in the greatest condition. It's a copy of a copy of a copy of a copy from years of teaching, so they're a little blurry, but I'll do my best.
Or are you going to catch another big time dub tonight?
This would be a major upset. Yeah, I'm hoping. We got to come out.
That'd be, what, 3 upsets?